Assalamualaikum. My name is Nuralizarti, and today we have another paper presentation. This is another interesting paper made by Ming-Chun Jamshi, Wei Shun, and Yang Zhu. And this paper accepted in ACM, Transaction Multimedia Computing and Communication, and published on May 2019. And the paper title is Detecting Online Counterfeit Goods Seller Using Connection Discovery. So this paper presentation is a part of my mobile social network courses in Taiwan International Graduate Program, and this part belongs Prof. Chih-Wei Huang. Okay, let's start this presentation. This presentation contains 7 outlines. The first one is motivation, the intuition behind this paper, and second one is contribution in this paper, and then related work and Provost's framework, experiment result, conclusion, and the last one is discussion and further work. Some of them is based on my opinions. So we go to the first one is a motivation. So in the past, it's hard to become an online seller because there is a technical knowledge of system design and programming skills that were required. So recently, because of social media and e-commerce platforms, sellers have become able to set up an online store conveniently with just a few clicks and share the product image with a suitable text online. Such images are made widely accessible to others so that potential customer can easily access them by searching their text, or customer can follow sellers to receive new products information. So the number of online sellers has grown rapidly in the past few years, and product available range from ornament and electronics to almost everything. It is very easy to become a seller on such platforms. So the effect is the number of counterfeit products being sold online has increased substantially. Most online sellers do not have an online store, and it is not possible to investigate their goods before buying them, which makes detecting such a product is difficult. E-commerce like Amazon and Alibaba dedicated significant effort to removing counterfeit goods. However, they are still widely accessible, as counterfeit goods must be manually flagged and removed. And this approach creates challenge to e-commerce platform owner, brand owner, or even to custom officer, like using manual effort to detect a small number of counterfeit sellers from among the hundreds of thousands of sellers is inefficient, and is not scalable to the rapid growth of online sellers. So traditionally, detecting counterfeit sellers has been conducted by searching suitable text and then browsing seller whose product contain those texts. However, such seller may be disguising text such as like high quality brand and meaning. A text-based detection system will perform poorly at detecting the sellers. And in contrast, the image used on posts are more consistent than text. Like similar images are used for the same product across the seller, such as table, to display the product on Instagram. So seller often process the product image from their source with techniques such as watermarking, cropping, and so on before posting them on their own store. So in recent years, a lot of progress have been made in object recognition using convolutional neural networks, which are designed automatically learn features that are sensitive to detect targeted object using given sample for training. So because of that, this paper using a CNN base to optimize their algorithm and become a proposal framework. So that's the motivation of this paper. They want to propose a framework to detect the counterfeit and non-counterfeit seller. Okay, We can see here there is this is a figure that that's a seller, a counterfeit seller, take a picture from the table, and they take the picture and they watermark it to claim it as their product. And another method, maybe they use, like, they tag this official picture from the official website, and then they crop it and they put it on Instagram. So what is this, the contribution of this paper? The contribution of this paper is they collected 473,000 search images from Instagram, Taobao, and Carousel. Instagram is social media, and Taobao and Carousel is like a e-commerce platform. And then after that, they analyze the behavior of the counterfeit seller using object recognition and connection discovery approach. And after that, they propose an optimized framework, and they conduct a showcase to prove the proposed framework. So we will talk about related work about in this same topic, and a lot of research have been done to detecting abnormal users. So the similarity of this paper and the others in state of the art is like they are detecting abnormal user. Like we see here is I try to figure it is using a XMind to mapping the related words. First one is like investigated the social information among users, so they detected using social information among user, and a lot of paper for discovering influential and then key user and negative user. Key user is just like a page rank based approach, and negative user to detect a hidden paid poster, a fake review, or even like another fake review here. And the problem is counterfeit product generated by individual instead of computer, and this social information is not available, so we cannot use this as a baseline for the research. And the second one, there is another previous research about detecting abnormal user, especially counterfeiting activities by using supply chain in social network. And the problem is most counterfeit sellers are independent, and their supply chain is offline and difficult to find with this method, so it's no. And the third one is like analyze content shared by user. It's used to detect like cyberbullying and then spotting the fake review and even detection of hidden paid poster. But the problem is this technique prefer to process the text. So to detecting abnormal user, we can use like discovering discovering connection, and it's already used by another paper. So for this, they improved to discovering connection. They using a CNN, and they are optimizing using Siamese network. So this paper will be the baseline of the this fourth paper will be the baseline of this paper. Okay, we want to talk about proposed framework. This is the flow of the proposed framework. Like we can see, there is a non-counterfeit seller. They use like non-counterfeit seller and other sellers, and they try to find the connection discovery between the counterfeit seller and non-counterfeit seller. And after they have discovered the connections, there is like a similarity, there is a link. Is it have a no similarity, weak similarity, or strong similarity? Or we can say that there is a no connection, weak connection, or strong connection. With that, we can detect the counterfeit seller by rank descending connection strength. So this is the system flow of the connection discovery. From this, there is a, for example, there is a three sellers, 1, 2, and 3, and they have a product. Seller 1 have a shoes product, and seller 2 have a shoes product, and the seller 3 have the like clothes product. And this product image will be encoded by using CNN, and they determine the feature factors of this, and the feature factors helping to do a clustering for assume A is like a shoes product and B is like a clothes product. After that, they label it using machine generated label, like this. This is becomes A because it's shoes, and this is become B because this is clothes. And they do distribution learning to map this seller became A labeled, and this one become mixed, and the third one is B. It's like a cloth. And after that, they do see the connection between it. Is that they have a no connection, strong connection, or weak connection. For this picture, we can see that seller 1 and seller 2 have a strong connection because they sell similar product, and seller 2 and seller 3 have a weak because seller 2 also sell the similar product from the seller 3, and seller 1 and seller 3 have no connection because they are sell different product. So to do that, they do like image encoding. So recently CNN have become the most successful techniques in visual object recognition, and CNN is inspired by the human visual system, in which neurons are arranged to respond to small facial region. And the structure of a CNN comprises several layers on nonlinear feature detector, and which are handcrafted with learnable weight and bias from data. The CNN is trained in a supervised manner, in which once the network architecture is defined, the training is just to give the input, and the desired output object is an image. So images are encoded using a CNN, as it provides the best performance in an object recognition. As the CNN is trained and designed for object recognition, images are encoded such that they are sensitive to object in an image. However, this may not be possible in the case of counterfeit seller detection, because as the difference between non-counterfeit and counterfeit sellers might not be the object in their seller image. Hence, they are motivated to investigate how to optimize the weight of a CNN so they can be sensitive to visual feature. So a novel idea proposed in this section is to optimize W, weight of this, so that it can help to detect counterfeit seller. One of the possible objective is to minimize the distance among images of counterfeit seller, and to minimize that among non-counterfeit seller, as well as to maximize that between counterfeit and non-counterfeit. So as results, the images from related pairs are more likely to be annotated with similar machine generated label, while the image from unrelated pairs are less likely to be annotated with the same machine generated labels. So the counterfeit sellers have a more similar seller profile, and training a classifier to identify those sellers would be more effective. So conventionally, W can be optimized using Siamese network, in which W is optimized by minimizing the distance between images of related pairs and maximizing the distance between images that unrelated pairs. However, one of the drawbacks of Siamese network is that the training does not always give reasonable result. For example, the images are encoded to 0, which cannot be used for further information. So after that, they like discovering the connection among seller. They do like a discovering connection, The discovering connection between any two sellers is defined as their similarity. For each image is encoded into a vector vector using an image processing and computer vision technique. And if the images are encoded using object-based encoder such as a ResNet, then the images in the same cluster are more likely to be with the same object. So that's why they use like a connection discovery to detect the counterfeit and non-counterfeit seller. To do that, they have a hypothesis testing of counterfeit seller detection. They have two hypotheses here. First one is H null. The seller I is a counterfeit seller, and H1, the seller I is not a counterfeit seller. So for these two hypotheses, there are four possible outcomes when a decision is made. First one, the decision is called a true positive when the algorithms select H1 when H1 is in fact true, and the algorithm selects true, so it's become the true positive. And if algorithm choose H null, but the fact is it's true, so it's become like false negative. So likewise, when H null is in fact true and the algorithm picking H1, so it's become a false positive. And when the algorithm picking H null and when the H null is true, so it's become the true negative. And a binary classifier is proposed for hypothesis testing. In the training of the binary classifier, a seller is labeled as a counterfeit or a non-counterfeit seller with an expected output of 1 and 0 respectively. And the binary classifier gives an output range from 0 to 1, with a 0 representing certainly that user is a non-counterfeit seller, and 1 representing that the user is a counterfeit seller. So for that, they can detect the counterfeit and non-counterfeit using these two hypotheses. And now we're talking about the data set. They collect the data set from Taobao. Taobao is like e-commerce, China's e-commerce platform, and they choose these two products, is shoes and cosmetic, because this two one is the most common product in Taobao. So they gather more than 100,000 images for a shoes product, and then they collect like 50 images from cosmetic, and they collect it from 38 counterfeit sellers and 55 non-counterfeit, and 23 counterfeit seller and 77% non-counterfeit seller for cosmetic product. And they collect data using octosparse, and they have a limitation of, they set the image minimum size of image is 400 multiple 400, because they want to avoid the interference of thumbnail and advertising image. And the information they collect just not only an image, they also collect the price of the product, and this data will be labeled manually with 14 experienced shoppers, and they label it as counterfeit and non-counterfeit using these three parameters: the display of the web page, and then or the shop page, and the price of the product, and also the image of the product. So this one is the example of image from a counterfeit seller and a non-counterfeit seller. By human vision, we can know which one is like a counterfeit and non-counterfeit. For this picture, the counterfeit seller has more simple shop page and display, and the picture taken is not professionally, and they add a lot of watermark on their product. And in normal seller, they have a very impressive display, and they took the photo with professional style, and like this. Even they do not have like a profile picture for the shop, so we can know which one is like a normal seller, which one is like a counterfeit seller. So by see this web page and this image of the product and the price of the product, the 14 experienced shoppers labeled the shop as a counterfeit and non-counterfeit. So they do like quantitative measurement. First one, they do quantitative measurement using discovery connection using object recognition. Object recognition is a very common way to detect what a seller is selling. Is it conceivable that among the same types of seller, the goods they sell must have a certain relevancy? And this picture shows the measurement between counterfeit and non-counterfeit seller from the object recognition perspective. And it is observed that most related pairs have a high similarity, and for both shoes and cosmetic seller. This one is shoe seller and this one is cosmetic sellers. They have like a high similarity, maybe because the reason is that the sellers are selling the same types of goods, and so the similarity is high among them. And after that, they use like quantitative measurement using discovering new connection using machine generate label. In this one, they measure counterfeit and non-counterfeit seller using machine generate label, and it's applied to check every image with a machine generate label, and user profile are built based on occurrence of the label. And similarity is computed using equation. From this image, we can see that CDFT have they calculate this measurement, and they are comparing within similarity and log probability densities function, LPDF, and CDFT have a persistent value. CDFT is a connection discovery fit tune using CNN, and CD is only connection discovery, and object is like object recognition. So from this picture, we can observe that the most pair have a similarity of 0.4 to 0.5, and this is motivated the writer to investigate how this method will affect the detection. So we will talking about the experimental results. These results from this figure, we can see that the precision of detection for number of iterations in training by shoe sellers and cosmetic sellers, they do like 20 iterations here, and the CDFT have a very high F1 score, very high F1 score. It's almost 90%. And in cosmetic seller, CDFT also have a very high compared to another method. So in precision of detection for different values of K for a shoe seller and cosmetic seller, they do like they determine the K is until 3000. From here we can see that the CDFT also have a very high value, and they compare it with CD, connection discovery, CDFT using CNN, and CDIFT using Siemens network. So because of this experimental result, they believe that the new purpose algorithm is very fit to use to detect the counterfeit and non-counterfeit seller. So they do some showcase to prove that the algorithm is work. First, they do showcase with Instagram. They collect about 60,000 images from 138 sellers, and they gather this data using hashtag HeyK online store. And the second one, they collect data from Carousel. It's another e-commerce platform, and they collect more than 250,000 images from 785 sellers with the category searching is men's top, women's top, design and craft, everything else. And they do this collected data with using Scrapy because there is no API available to scrape this data from Carousel. So from this picture we can see that the proposed framework can have high precision and recall compare the manual profile, the manual way to detect the counterfeit sellers. And they do showcase to table seller detection on Instagram. They from the 138 Instagram sellers, they check it manually and they have labeled it on it. If the Instagram seller have a 50% similar product with the table, so they will be labeled as a table seller. And in fact, there is a 33 sellers, table sellers in 138 Instagram seller, and the algorithm can determine 70 sellers as a table seller. So we can conclude that 60% this algorithm can detect the table sellers. So there is an error analysis for this proposed algorithm. Like this this algorithm for, like, we can know that there is a 3 different method that they use, that the writer try to use. First one is object based, but the object based is failed to detect if the similarity is high, and the CD based is failed to detect if the images have a similar visuality, and the CDFT, the labeled manual by information of web page for each image, so they cannot determine difference between counterfeit and non-counterfeit. And because of that, the differences are obvious for humans, because image from non-counterfeit seller, we can see that they taken against a white background and they took it professionally, while the image from the counterfeit seller are taken against various background, a lot of background here, so we can know. And object recognition approach cannot give good classification result for that. And I've observed that they are shared visually similar image from here. They all have like back have almost same position, and there is a like text here. So CD based is failed to detect if the image have a similar visuality. And the CDFT observed that images shared by the counterfeit and non-counterfeit seller are similar, as the seller are labeled by information like a seller, web page, and price, image. So it's very difficult to determine difference between counterfeit and non-counterfeit based on the object. So the conclusion of this paper is this article proposed a framework to detect online counterfeit seller who previously had to be manually detected, and CNN-based connection discovery framework is proposed to help the detection the counterfeit and non-counterfeit seller. And this paper do experimental conducted with a real life data set with over 400 50K search images from the social media e-commerce platforms like Temu, Instagram, and Carousels. And the framework can achieve over 90% if F1 score for detecting the counterfeit seller, and as far as they are knowledge that this is the first work to detect online counterfeit sellers from their share image. And we go to the discussion and future work here. This is based on my opinions. We're talking about data set, and the first of the paper they talk that the collected data set is from reported or punished counterfeit seller. But in the middle of the paper, in the dataset chapter, they told that the dataset is collected manually, labeled. So after the dataset collected, the counterfeit and non-counterfeit seller manually labeled by 40 online shopper. So it's like become a question, which one is true. They are labeled is manually or from the original data, like reliable data from reliable research, like reported or punished counterfeit seller, because it can affect the performance of the algorithm. So, and after that we're talking about continuous learning. The training set is limited and need manually verify if there is a new type. For example, if there is a one or two new counterfeit sellers that they make a new account and then they share the image, we still need human to manually verify, to see the web page, to see the picture, to see the price and label it as a counterfeit. So it's become a question: is that a continuous learning for machine learning, because they're verified manually? And the third one is CDFT is not object-based detection, because they use another information like the web page and then the price of the product, and they use the object based only for the input in the first algorithm, but for labeling they use another information. And about the future work, in my opinion, how about we incorporate the object with the CDFT, so the real object have like star image, and the object have like a feature value that can use to determine the similarity with one product to another, if it's possible to combine with like a connection discovery. And after that, how can we investigate different parameters such as the number of unique machines, and can we use like CDFT sim with big data training, because CDFT sim good in computational performance? Or can we use another method for feature extraction such as copy, move, watermarking, rotating, and flipping, because this techniques is not described in this paper, and some of counterfeit seller use this technique to take like a visual picture, a visual image, and then claim it as their own. And can we use like metadata information to as a parameter to do like connection discovery, not only the like a profile user? So what if we want still use like object based images? What if we using CNN based object detection algorithm by joining semantic segmentation for image? Because in 2020 there is a paper that used this algorithm, and in this one they use ResNet, and there is a prediction part here and some semantic segmentation. So instead of use like object recognition for the clustering and then using discovering connection to determine the counterfeit and non-counterfeit, what if we like combining in one framework and using another feature to detect counterfeit seller, like metadata from the image like I said before, and user review or user profile. And what if we like automatic counterfeit or non-counterfeit labeling, because the problem of this paper, I think they label it manually by 14 experienced shoppers. I do not know what the scale of the experienced shoppers, and so the label manually based on their assumption. So based on their assumption, so it's not available to set as a data set for this research, in my opinion. So we goes to the question. This question is come from my first presentation, and this question is from my friend. First question is from Wendy. How do you know if the online product is real, and like how you can tell that the seller is fake or real? So to determine is a like a counterfeit or not counterfeit, or seller is a fake or is a real, they use like a human to manually label it. So there is a 14 experienced shopper in this paper, and they determine the counterfeit and non-counterfeit based on the display of the shop page, and then the price of the product and the image of the product. And the second question is how to identify or eliminate counterfeit in a website like Amazon. As far as I know, Amazon is trying to dedicate their time to manually remove it. I do not know about the algorithm that they use, but in this paper they talk that Amazon using manual label to remove the tag, suitable tag, to remove the counterfeit product. But in this paper they use dataset from Tableau, and they believe this algorithm can be used in Amazon. Okay, and the question from Daya is how they implement CMS network in the system. And to answer that, we have to know in CNN model we have a series of convolutional and pooling layers followed by some dense layers, and output layer probably with a softmax function. And the convolutional layer here are responsible for feature extraction from the images, and where the softmax layer is responsible for providing a range of probability for every class. And they decided the class of the image with the neuron that has the highest probability value. In this paper they left a PDF probability density function. And with CMS network, it has a similar with convolutional and pooling layer, except in CMS they don't have a softmax layer. So they stop with the dense layer. As explained, since the network has two images as an input, and it will end up with two dense of layer, and so can calculate the difference of those two layers and output the result to a single neuron with a sigmoid function 0 to 1. Thus the training data to this network must be structured in such a way that there is a list consisting of two images and a variable either 0 or 1. So they have almost have a same structure, but the difference is the CMS network do not have do not have a softmax layer, so they stop in the dense layer. And the difference is the CMS network. Why they don't use CMS network? Because CMS network very strength in little data set like 100, 1000, and CNN is more fit to use in a huge data set. I hope that can answer your questions. And how if the seller is selling second-hand goods, because the classification only based on image and price? Yeah, that's a good question. Unfortunately, this paper have a limitation. They only focus on like a visual and non-visual, counterfeit and non-counterfeit. So they are not telling about a shop that's selling a second-hand goods. So they are just dividing this become a visual one. For example, the shop that visually sell Adidas or Ager or like a net product, and the other one is they are not official one, so they don't telling about the selling second-hand goods. Okay, the next question is from Tatir. Tatir asks about, do they deal with the problem if the image are of real product but the actually product are those who were in the images? Yes, of course they deal with it. Then they try to extract the extract. They do a feature extraction to deal with this problem. They use like image processing and computer vision technique. Because of that, they use CNN. And how do they differentiate between copy item and the original item, as both products are almost similar? Yeah, that's become a limitation of this paper, because they do not, like I said before, I put this one like a copy moving, rotating, and watermarking method, because they don't explain much about the technique that can handle with this algorithm. So I'm not sure how to explain about how they differentiate between copy items and original items, because in this paper they're not telling as much as we expected about that technique. And in Joshua is, why did the paper use image and some other information for modeling but claim it only use image based algorithm? Okay, so for the input on the algorithm, they using like image, but to determine the counterfeit or non-counterfeit, manually they use another information. So in their perspective, maybe because the input is the image, so they concluded it's like image-based algorithm. I believe that's become one of their reasons to call it image-based algorithm. And also in the title of this paper, they push it on the connection discovery, and connection discovery using another information rather than only image-based. So I hope that can answer the question. And another question, can we improve it in the future? Yes, of course, because this paper have a lot of limitation, especially on the data set, and they label it manually, and it become not reliable in my opinion. So I think we can improve about this paper in the future. Thank you. That's the question, and this one is the reference that I use. And thank you for your attention. Assalamualaikum.